Okay, good morning or afternoon, ladies and gents. Now, following on from our geometric use of vectors, what we're going to go on to now is something called the scalar product. Guys, I'm going to say it's called the scalar product, and I promise you in any textbook it is, but we're going to effectively call it the dot product from the remainder of this. So for this lesson, we want to understand how to find the dot product of two vectors. Now, what is the dot product? It is effectively scalar products that are the operation of two vectors which give or provide a real number. This number represents how much of a vector is in the direction of another vector. Now for this here, the dot product is actually quite simplistic. There is a proof to it that we're going to look at in a moment, but the mathematics is not as hard as you might think. So the dot product formula. You can see that if we had it in, well, ijk components, so one of the three versions of Cartesian form, if vector A goes at a1i plus a1j plus a1k, and just in case you don't know what that k is, three-dimensional. When we go into complex numbers and further, you'll be seeing it a bit more often. And for vector B, its components are b1i plus b1j plus b2k, or b2, sorry, here. For the dot product, all we do is multiply the like components. So anything with the i's, you multiply together, plus anything with the j's, you multiply together, plus anything with the k's, you multiply together. Nice and easy. So let's look at our first example. If vector A in Cartesian form is -1, 2, and vector B in Cartesian form is 1, 3, find the dot product. Well, if we were to convert this back to ijk, i's, j's, x's, y's. So what we need to do here, I'm not sure why I've done here we go. For our dot product, we show vector A times vector B. So the dot product, you show the multiplication between our two vectors, in this case in Cartesian form. You then multiply the x components together plus the y components together. It gives you our two real numbers. Add them together, you get your answer. Plain and simple. The thing is though, now that we've just began with our proofs, you need to observe something that's a little bit worthy that I expect you guys to pause and have a good read through. Are you required to write this down? No, not yet. Will you need to in your futures? 100%. So what I want you guys to do is I want you to stop. I want you to pause the video, and I want you to spend a good 5 or so minutes reading this and observing how we've simplified from this component into this component. Pause, watch it now. All right, so guys, for the geometric description of a dot product, if you've got two vectors going from the same origin, we know that we're going to have an angle in between. For our geometric use, if we're adding these together, it's not going to be a plus b, it'll be a minus b. So for the dot product of a and b, dot product, it'd be the absolute of a multiplied by the absolute of b cos of the angle in between. Simple as that. So let's go for our example 2. Even easier. If the absolute of A is 4, and the absolute of B is 5, and the angle in between vector A and vector B is 30 degrees, find the dot product. For this, you write your formula. You literally substitute the three values you have. 4 times 5 is 20. 20 cos 30. Plug it into your calculator. That's your answer. It's very quick, but it allows you to get your answers there. Here's where it gets slightly trickier. If we want to find the angle in between two vectors, or the magnitude of a particular vector, you just need to work in reverse. The key thing to remember, this is the formula you work with. So if you just wanted to find the angle of something, well, if we're looking at cos of angle for the original formula, to find the angle, it'd have to be inverse cos, and then you do your multiplication and division. If you wanted to find the absolute of vector A, so the magnitude of vector A, you just have to rearrange it so A is on its own, right here. And if you wanted to find the magnitude of vector B, well, same thing. I would suggest, guys, pause the video, write all of these down, and either box them up or put big giant asterisks next to them, because this is what we're using for the next bit. All right. Third and final example. I'll let you guys guess what we're going to work on next. For example 3, if vector A has the coordinates 2, -3, and vector B is at the coordinates 2, 1, determine the angle in between them. Well, for this, guys, we've got our vectors A and B. We know that our dot product between them is going to give an answer of 1, but we also need to figure out our magnitudes for both of them to figure out our respective angle. So, the magnitude for A, we use Pythagoras. Square root of x squared plus y squared gives us root 13. The magnitude of B, Pythagoras, square root of x squared plus y squared gives us root 5. Leave them as this. It's going to make it easier. Absolutes, you always want to leave them as surds. You then go back to our angle formula for this. The angle is inverse cos of dot product divided by the multiplication of our magnitudes. So in this case, inverse cos of 1 over root 13 root 5, which gives our answer at 82.875 degrees. Simple as that. So give it a shot, guys. Smash through those questions, and I'll see you in the next one.